over the past couple of years, I've gotten to know Vani, and she is such a great moderator, and she's such a subject matter expert that you guys are in for a treat. I'm really happy that she's moderating this session. We previously had Molly Wood, Molly Wood's great as well, but this session is a really cool topic that Vani, you can go into with your panelists. So Vani Estes, VP of Innovation for the International Fresh Produce Association, come on up with all your panelists. All right, thank you, Vani. Take it away.
All right. Thank you. And thanks, everybody, for joining us for this panel. And as Michael said, I'm the Vice President of Innovation for the International Fresh Produce Association, and we work across the entire supply chain, all the way from crop inputs, like breeding and crop protection, through growing, through supply chain, through retailers, and we're a global organization. So I really get to work across the entire supply chain in getting great produce to people like you. And unlike almost everything at CES and the last panel, we are not talking about AI. But we are talking about something that's equally as transformational as AI and is going to have almost as big an impact, I think, on us as a society, and that is gene editing and new breeding techniques. And I imagine that many of you have heard of gene editing being used with human health and fighting and mitigating different diseases, but we're also using it in crops and livestock. And that's the subject of our conversation today, is to really look at how these new breeding techniques are going to change the food that we eat and the entire supply chain of how we grow and produce food. So I'm going to have my great panelists that have very different perspectives and come from different places and different backgrounds introduce themselves. So your name, your company, and a little bit about what you do. And Sarah, we'll start with you.
Great, thanks, Vani, and great to be here. Thanks, Michael, for the invitation and for hosting us all, and for really bringing food and ag into this future forward forum. It's so important. My name is Sarah Vanja. I'm a plant scientist by training, but today I serve as the Vice President of Business Development at Okanagan Specialty Fruits. We are a pioneer, really, in embracing biotechnology to actually develop products that are now on the marketplace. So we developed non-browning Arctic apples using the tools of bioengineering, or it's a GMO, if you will. And today those apples are sold all across the country. And today we continue to innovate across specialty crops. We are using the tools of genome editing, CRISPR, if you will, to bring new traits into mostly fruit tree crops, and working on traits that are of benefit to consumers as well as benefits to growers.
Ian Miller, I'm the COO of Pairwise. At Pairwise, we're using these technologies, specifically CRISPR, to really tackle the big challenges we have in our food and agriculture system today. With a growing population, increasing climate pressure, some of that is doing more with less. Feed more people on less land, less water, fewer inputs. And we're collaborating with some of the largest seed companies in the world, Bayer and Corteva, working on crops that really cover hundreds of millions of acres. Think corn and soy, potentially really big impact to bring those benefits to the world. But it's not just about corn and soy. It's also about what you and I eat in the produce aisle every day. And some of that, of course, is making those products more sustainable and more productive. But it's also helping to reduce the barriers to consumption of these healthy items. So we launched the first CRISPR produce item in North America over a year ago. It was a high nutrition leafy green, and we're also working on seedless berries and the aforementioned Pitless Cherries that's in the title. So thanks.
Yeah, thanks for including me on this panel. My name is John Oatley. I have the role of Associate Dean for Research and Professor in the College of Veterinary Medicine at Washington State University. In those roles, I direct a research program that focuses on enhancing the traits of food animals using gene editing technologies. We work across the spectrum of livestock, including cattle and pigs and goats and sheep, to try to engineer traits for things like disease resistance, increasing performance of the animals, improving the welfare of the animals. I'm also involved in several efforts at trying to harmonize and modernize the regulatory systems globally to try to create a barrier-free way to introduce food products from gene-edited animals into the human food supply. So thanks for having me.
Great. What a great panelist. We really have expertise in lots of different areas. So let's start sort of big picture here and start with two big picture issues, which is one, we talked a little bit about the impact on the food production system, and then also we'll talk a little bit about consumer engagement and acceptance. So Ian, why don't we start with you? And you all three have very different perspectives. So talk about how gene editing can impact the food production system today and what you're seeing.
So maybe just to step up one level, that the impact that genetics can have in general on plants. Genetics affect everything from, the color of your tomato to its shelf life, to how much it yields. And and breeders have utilized this for a very, very long time, but it's a very slow process. Gene editing really accelerates that. It's like the equivalent of going from punch cards maybe to microprocessors in the ability to do that. So you can do things like not only create things that are seedless or pitless, as we talked about, but imagine all the other things that you can do architecturally with the plant to really potentially revolutionize the way that the cropping system is done. So we're producing the seedless blackberry they're producing is also compact and therefore is much higher yielding. It also has no thorns, which actually reduces labor costs and is a worker safety issue. So there's a potential for this technology to really completely transform the entirety of the chain. And so that pitless cherry, for example, is no longer grown on a tree, but it can be in a bush, which could be put in a hoop house near production centers. So I think the ability to both reduce cost, increase value to grower and consumer is really profound with this technology.
Thanks. John, what about you in the world of animals and livestock? What do you see?
Yeah, so in the food animal world, essentially all gene editing applications boil down to improving production efficiency. The guiding principle, being similar to echo what Ian has said, the guiding principle is that the trajectory of human population growth is going to put 10 billion people on the planet somewhere around the year 2050. And to be able to provide food security for that number of people, it's going to require an increase in agricultural production, both plant and animal, by 60%. And conventional strategies to breeding just aren't going to cut it because they're incremental oftentimes and slow to materialize gains. And so gene editing is going to have to be used as a tool. And in the food animal world, you can think about using gene editing to make rapid advances in things like thermotolerance or growth efficiency of animals. That means they need to spend less days on feed to hit a marketable weight. That means they're also going to have less impact on the environment. Things like improving their reproductive capacity, because we need to be able to integrate genetics across large numbers of animals and populations globally. We can think about improving welfare of animals, overcoming some of these standard husbandry practices that reduces the thriftiness of the animals. And we can think about things like biodefensing our nation's food supply against really contagious pathogens that have outbreaks and reduce food supply globally. Gene editing offers an opportunity to be able to do that in single generations rather than having to go 5, 10 plus generations and decades to make incremental advances. We can do it rapidly with gene editing. And I think without it, we're not going to be able to feed the future in a sustainable way as population grows.
So the way that gene editing makes this easier is, one, before gene editing, you would just have to do more traditional types of breeding, which takes longer. But can you take an example like disease resistance or whatever example you want to take and explain a little bit, like what does gene editing do that makes it better than traditional?
Yeah, disease resistance is a great example. So, historically, traditionally, the way that you would look for genetics that confer disease resistance is screen populations of hundreds of thousands of millions of animals for that rare individual that can survive an exposure to a pathogen, and then try to use that individual to propagate those genetics. That one individual is hard to find, and most producers, if there's a disease outbreak, they're not screening for an individual animal that's going to survive because it's got a mutation in some gene that's allowing for that survival. They're just going to get rid of the population. They're not going to try to select for it. And so the more that we know about how viruses and other pathogens infect cells and cause disease, then we can start identifying gene candidates to then use gene editing to modify, and therefore start integrating a genome into production populations that are going to be resistant or resilient. The animals are going to bounce back from the disease. And so we can do that in 1 or 2 generations versus screening, and purposefully in a precise way, versus screening huge amounts of animals looking for that rare individual and then hoping we're going to be able to propagate those genetics in a large scale way.
Excellent, that's really clear. Sarah, from your point of view and looking at how this technology and breeding can really affect the food production system, talk a little bit about shifting diets and nutritional needs, and kind of from a consumer point of view and a health point of view, what impact can this have?
Yeah, absolutely. Thanks, Bonnie. We're all here in Las Vegas at a conference, so I call this the conference diet, that we're on this week. How many of you actually managed to eat a fruit today? Yeah, I mean, it's dark out there, but it's not looking good. And the statistics aren't either. I mean, to be serious, the numbers say that, only 1 in 10 U.S. adults will consume the recommended daily amount of fruits and vegetables on a daily basis. I thought this would be a special audience, but it turns out we're not so special. Kids on average in the U.S., only 1 in 2 will eat a daily serving of fruit. And so we're not consuming enough fruits and vegetables, and this has had a huge impact on our dietary crisis across the country and, really in various places all around the world. And that's in part due to the way that we're consuming food today. We do a lot of snacking. Increasingly, all of our eating occasions are really snacking occasions. And when we think about what's available as snacks, and I speak from a U.S. perspective here, it doesn't look so good, right? I mean, when we're on the go and we're trying to, pick up a few calories to carry us to the next meal, it's often junk food that we're opting for, not fresh produce, right? And so, we have a huge opportunity really to use tools like gene editing to really fuel innovation in specialty crops that populate our produce aisles. And I think that's where such an exciting opportunity is. And this is obviously very important for our own personal nutrition health and health and well-being. But it's also got a huge planetary dimension. So as we shift our diets and are compelled to consume more fruits and vegetables, we have less of a negative impact on the environment in terms of our personal contributions to greenhouse gas emissions. So there's a huge planetary benefit. And then, of course, very central to the work that our company has done in terms of really trying to use biotechnology to decrease food loss and food waste, we're able to use these technologies to extend the shelf life of products and reduce food loss in the field as well as food waste in consumers' homes using this technology. So I think it's just a really exciting technology where we're able to present benefits to both people and the planet. And we know that, when you ask consumers what would drive them to really get excited about gene editing, we know from a study that was done at Cornell, for example, that consumers, they're very excited about applications of gene editing that will bring them a personal nutrition benefit. So that's where, applying editing to fruits and vegetables is really going to deliver on that consumer ask. And secondly, they're very interested in applications of gene editing that are going to make food production more sustainable. And what rises to the top there is decreased pesticide use. And so when we talk about using these tools for disease resistance, for example, in the context of agriculture, and cropping systems, we're able to use these tools to really reduce pesticide use in our cropping systems. So great win for people and the planet.
So I think for crops it's similar to what we were talking about with animals, is that we can just do the work so much faster and look at disease resistance. Looking a little more, just to make it really concrete for people, talk a little bit about your non-browning apples and how those are used in schools and how really practically it's getting more apples eaten and less food waste.
Yeah, so our company, one of the things I really like about our story is, we were founded, a couple of decades ago, not because the tools of biotechnology came online and we were like, okay, what can we do with this cool new tool? Rather, our founder, had worked building farms around the world, came back to British Columbia, started an orchard business of his own, growing apples and cherries, and really was shocked to realize that 50% of all apples were lost or wasted as you moved from the orchard all the way to the consumer. And so that was unacceptable for him, and he went out looking for a solution. This is the late 1990s, and he discovered biotechnology and realized that if you turn down one gene that causes enzymatic browning, you could reduce waste in the orchard that's due to finger bruising when picking the apple, bin bruising when moving the apples around, and then all the way along the supply chain to extending the shelf life for consumers with just the tuning down of one gene. And so that was really the birth of our business and the Arctic Apple story. Today, we are a fully vertically integrated company, so we do all the biotechnology in our labs, we grow all of our trees in Washington State, and then we have a state-of-the-art processing facility where we slice and dice apples. So we sell only sliced and diced apples, which means that we're only shipping out the part of the apple that people are actually going to consume. So that's another elimination of waste and another way that we're able to really lessen our environmental footprint. So when you don't ship the part of the apple that people don't eat, the core, you're able to reduce your freight weight by 20 to 30%, and you're also able to control what happens to that apple core and make sure that it's used in a sustainable way, and ideally put back into the food system in the form of cattle feed, for example. So that's the way that one simple genetic tweak can have a huge impact, both in terms of reducing food loss, food waste, and making it more convenient to eat apples and driving consumption across the U.S. population.
Thanks. The other big picture issue I wanted to touch on is really looking at consumer acceptance, and it'd be interesting if I could see the audience to have a show of hands, but I won't ask. I think this audience skews a little bit younger, and we've at International Fresh Produce Association, we've done a lot of work at going out and talking to consumers about their views on advanced breeding techniques, and it's really changing a lot over time, and part of that has something to do with COVID, where people are like, technology can save lives and are a little more accepting, and some of it is just younger people's acceptance of technology overall. So there was, years ago when genetically modified organisms first came out and we started, we had a lot of traits that were in row crops, there was a backlash to that. And now a lot of us that have been around for a while are very considerate of making sure that we're transparent with consumers and that we're communicating what's going into their food and the technology that's going into their food. But I would say, from what I see in our organization, is that it's like the jury's not out anymore. We've kind of made a decision, and in our title, we've got pink pineapple in the title, and that's a product that's genetically modified on the market that Del Monte researched and produced, and people are buying it. They're buying the Arctic apples. They bought the conscious greens from Pairwise. I can't speak to animals, so we'll have to ask John about that. But so consumers are buying these products and they're accepting these products. So that's my stance, obviously, but I'd love to hear from you all of like what you're thinking about consumer acceptance and how big a barrier does it continue to be. And John, why don't we start with you and what you're seeing in the animal world?
Yeah, I think over time it's become less of a concern. And so the experience that we had is a few years ago we were able to obtain FDA authorization to process some pigs that were carrying CRISPR modified DNA, and we got authorized to be able to process those for human consumption. And so we did. We turned them into sausage and we made it available to the public, and we had cookouts and we provided it to people, and by and large most people didn't seem to care. I think sometimes we overinflate the general public's attitude towards biotechnology. I think by and large most people want food that is nutritious and as cheap as possible. And if we can guarantee it's safe, I'm not sure they really worry about how it's made. They just want access to food. And so I was pleasantly surprised that most people didn't seem to have a negative response to consuming a animal protein that was coming from animals that carried CRISPR modified DNA. So I think we're doing really well. I think it's a positive trajectory on with that. And I think the areas where there's still concern boil down to just lack of knowledge, lack of education about what genetics is, how DNA works, what CRISPR modification or other gene editing modification actually does to the animal. And I think the more that we are transparent in the way that we're producing the animals, and the more that we're providing knowledge that's palatable, if you will, for people to understand how it's made, the more accepted it's going to be.
Ian, what about you? Talk about some of your experiences that you had at Pairwise around the conscious greens.
Yeah, one of the theses of the company when it was started was that one of the challenges with some of the original GMO products was that the benefit to consumers was indirect. So it was largely that benefit was conferred to farmers. And so, part of the thought process on focusing on consumer traits is also, help solve a problem for consumers. Give them a good product. And if people have a good product, of course, transparency is important. They care a lot less about how it gets made. And we saw this bear out with our greens product. Before launching, we took it to 3 different cities. We served 6,000 salads, and we got over 3,000 responses to surveys. And we were very transparent about the technology used in the process of that. But people were eating a salad, right? It was a tangible thing in front of them. The top 2 box for purchase intent was over 90%, and less than 1% said anything about the technology at all. And a lot of that was curiosity-based. So I think if we provide benefit to consumers, provide them a product, I think they will come.
Sarah, you've spent a lot of time in multiple occupations and roles of doing advocacy and talking to consumers and really working on shifting some of these public perceptions. What are you seeing, and how do you work with people to communicate in a way that they're willing to be open-minded about technology?
Yeah, well, Ian just said the key word, which is benefits. It's all about benefits, right? That's what drives our interest in purchasing any product, right? And, as was said, I think in the early days of GMOs, it was sort of easy to sort of instill this kind of GMO hesitancy because it was all very abstract. And none of us actually got to touch, feel, or smell a GMO, right? And it wasn't until the new products came online that are now available in the marketplace that we're able to do that. And a lot of this supermarket is full of, processed foods with genetically modified corn and soybean in there. And even then, that's not like something we really can identify with. But now we have purple tomatoes in the produce aisle. We have pink pineapples. We have our Arctic apples. And so there's actual products that you can enjoy that impart a benefit directly to consumers. And so, it's taken a while because science takes time, but now we have these really exciting products. And, the pink pineapples, those sales doubled from 2022 to 2023, so I'd call that a success, right? Consumers clearly like this pineapple. Purple tomatoes are now available in 3 major retailers, and they also have a direct-to-consumer strategy where they've sold last year 13,000 seed packets to home gardeners. And then, in terms of the Arctic apple, we can now say over 1 million servings served, right? So 100 million servings served. So clearly these products are successful in the marketplace, and they have benefits. The pink pineapple is a really novel, beautiful product. Purple tomatoes, also very beautiful, but also have this increased anthocyanin content, so really gets to that consumer interest in a personal nutrition benefit. And then our apples really making a healthy snack much more packable, much more convenient, so that we can embrace them in our rapid on-the-go lifestyles. So I think it's all about benefits. That's the bottom line. If you solve a problem that people have, they're going to purchase the product, and they don't care how it's made. But you need to be transparent.
And we're also seeing that, I think, as we're saying, using this kind of technology is allowing for more sustainable growing practices, and being able to tie those together. I think I've felt really strongly we needed to lead with consumer benefits, but now as we're getting more acceptance and adoption, I think tying that together with sustainability is really powerful, and that's where we are now. Did you want to say something? No. So let's move on to innovation and adoption. And John, let's go with you. From your experience, what are the biggest regulatory barriers for scaling gene-edited crops, gene-edited livestock globally, and how do we overcome those barriers?
Yeah, I think there's two major issues with the regulatory systems globally now. The first is misalignment to the science. A lot of the regulatory systems have had ambiguity, which has made it very difficult for developers to figure out how to navigate it. There's also been issues of concerns raised that I would say are issues that lack empirical evidence or science-based evidence to be a true concern. For example, the off-target or unintended editing that might happen by a CRISPR. It's almost impossible to figure that out in an animal because every generation they incur new mutations naturally. It's almost impossible to figure out what's CRISPR-induced versus naturally induced through just deficiencies in DNA repair. The other is the change in the nutritional, the composition of the edible product of the animal. In the animal world, we really don't know what the range of normal looks like. Like the iron content depends on how the animal's fed and in what environment it's fed in, and it's such a range that if you actually got outside that range, the animal would probably be dead. So, but these things are issues that need to be addressed by regulatory agencies. And so aligning to the state of the science, I think is a big thing for modernizing the regulatory systems for the food world. The second thing is harmonizing globally. So you can imagine that getting a perfect regulatory system in the United States, if it's misaligned to a regulatory system in a country that's a major export market, it's a barrier, it's a non-starter. And so there's not harmonization globally on what our regulatory landscapes look like across countries. So I think we need to work better at harmonizing and aligning the regulatory systems to the state of the science.
Where does that happen? How does that alignment, what kind of agencies or global groups get together and make those decisions?
That's a great question. I think we do need a global consortium to come together in some sort of agreement, multi-nation agreement to say we're going to be a global regulatory agency for how gene-edited food animals are being introduced into the human food supply, and member countries are going to sign on and saying this is, we're aligned in what needs to be done to show the safety and the efficacy of whatever gene edit's being introduced. I think that there's not a lot of that being done. I've participated in a lot of workshops talking about the need to do that, but I haven't seen any material outcomes from those workshops. We spend a lot of time talking about the need to do a lot of things, but not a lot of time doing it.
So if a livestock producer in the U.S. wanted to export, is that an issue now, or would they be able to export meat to different countries that had different regulations?
Yeah, it all depends on the country. So some countries are close to, and the United States still hasn't figured this out. We're still in draft form with the FDA. There's still a discrepancy on whether the jurisdiction should continue to reside with the Food and Drug Administration or whether it should be with the U.S. Department of Agriculture, or maybe there should be some coordinated framework. It's still, the jury's out. I'm part of a National Academy committee that was chartered by Congress to scope out the state of research and development for gene editing in food animals, but also the regulatory space. We just wrapped up our committee work this winter, and we're going to have a report that's supposed to be presented to Congress this spring. And hopefully that report is going to help clarify some of the pinch points that need to be figured out in the U.S. system, and how relieving those pinch points are going to align globally to other countries. Some countries have already made decisions, rulings on what defines a GMO versus non-GMO in the food animal world. They've largely centered on if it can be brought about by natural breeding, then it's not considered a GMO. If it involves the introduction of foreign DNA sequence, then it is a GMO. In the US, we still don't have that distinction. So some countries and then other countries are completely closed off to it. It doesn't matter if you used a human intervention to bring about a change in the DNA, it's considered GMO no matter what. And so that closes off export markets from countries that have decided that it's not a GMO if it was brought about by something that could have come about by natural breeding.
Can I offer an alternative viewpoint? I actually don't have a lot of confidence that countries can come together and come up with a harmonized regulatory system. I don't think there's a lot of precedent for that. And I think the least common denominator is usually not good for progress. That said, I do think, in the last panel, they were talking about how desperation fuels adoption. And I think that's what we're seeing all around the world. Countries are realizing, like, wow, we've got a huge challenge ahead of us with climate change. We've got to be able to produce food sustainably. And the only way we're going to be able to do that is if we embrace new tools. And as a result, it's like every week, every month, every week, we see headlines that country X is revising their regulations on biotechnology, on gene editing, because they want to be able to use these tools to produce food more sustainably. And so I think it's that driver of desperation that really is loosening up this regulatory environment.
Well, and I think you see this as part of what's driving, at least in the crop space, Europe to open up its regulations. They have some very aggressive green objectives that they're trying to hit, and they just are not going to be able to hit it if they do not adopt these. I think the other piece is, showing demonstrated products where people, are a benefit to the growers of the countries in which these things are being produced is also really important. I think if we can get some products out there that show economic benefit, and therefore to the countries, they're looking and talking to their farmers, their growers. They either have to, help make the regulatory regime, more rational and more science-based, or they're going to leave their own constituents behind. And so I think there is some of that economic progress component of it that I think we can also help to bring it along.
Let's look at some of the major, kind of dig deeper into some of the major pain points that we have. And Sarah, what do you see as how gene editing can be used on some of the major grower pain points?
Yeah, growers have a lot of challenges, right? Disease pressure, for example, a changing climate, lots of biotic and abiotic stresses. But when I talk to growers, the number one topic, whether it's in fruit tree crops or other specialty crops, it's labor, labor, labor. And, if we just look at the apple industry, which, I'm intimately following, it's in a bad state of affairs in the U.S. So there was actually an article in the Seattle paper, Michael, this week that talked about the challenges in the perfect storm that's really causing a lot of challenges for the apple industry. Apple consumption is basically stagnated, and if you correct for population growth, it's actually declining. So people aren't eating apples like they used to. And the price of production has really increased. And growers aren't getting any more for an apple than they did 30 or 50 years ago. So it's an industry in crisis. And labor constitutes 60% of the production costs. And so it's a huge, part of, the expense of labor is a huge part of what's stressing the industry. And we probably can expect that that's going to become an even increasingly big challenge in the next administration, as was discussed in the last panel, with an even smaller labor pool than we have today. So labor is the biggest pain point for growers, I think, in specialty crops. Definitely came up in the last panel. And gene editing really has an interesting role to play there. So at Okanagan Specialty Fruits, we're really excited about thinking about how we can use these tools of gene editing to actually make changes in plant architecture that will make our crops more amenable to the great advances in automation that were just discussed in the last panel. So unlike row crops, specialty crops really haven't benefited from a lot of the robotics and automation that we see. We're still very dependent on manual labor. But if we can make small tweaks to the architecture of our plants, then they're going to be able to be much better positioned to harness those innovations in automation. So changing the stature to make our apple trees shorter so that they're more accessible for robotic harvesting, for example, is one way. And so that's why, including food and ag in a forum like this is so important, so that the folks like Ian and I who are interested in genetics can be really interacting with the people who are making advances in automation and robotics.
Yeah, another thing that we're seeing around, it's been mostly traditional breeding, but things like broccoli and lettuce, if we can make the stalk a little bit taller, then we can go in and cut it. We don't have to hand cut. So you still have people out in the field that are putting it in boxes and, putting it up on the conveyor belts, but you don't have people on the ground with knives anymore cutting if you can have a larger stalk. Ian, talk a little bit more, dig a little deeper into how gene editing is helping with climate change and climate resilience. What do you see is happening there?
Well, certainly, climate. From a climate change perspective, I would put it in two ways. One of them is, I think Sarah brought this up earlier, making fruits and vegetables more appealing, more available, et cetera. If we just shifted North America, we don't all have to be vegan. We can all shift North American diets by 10%. That's the equivalent of planting or doubling the forest size in California. It's a pretty profound effect. And there's lots of ways, I think, to deal with some of the challenges in animal agriculture and CO2 production. But that's one simple way to talk about it. From a climate resilience perspective, this goes back to the more with less type of notion. Gene editing you don't have to make the compromises that a breeder might make. So if you have a variety of soybean or corn or sorghum that is able to work on less water or higher temperatures, we can use this technology to increase its productivity and work through some of the other challenges that it might have in other ways. So I think there's a way for us to take these varieties that already exist out there and are naturally resistant to some of the challenges that climate change brings, and then we can fix other things related to productivity, disease resistance, et cetera.
So in the only 3 minutes we have left, I'll ask the obligatory question of what's the one aspect of this technology that excites or inspires you the most about its potential to shape the future of farming? And John, let's start with you.
Yeah, I think it falls in two buckets. One is disease resistance. If you ask livestock producers, what keeps them awake at night, is the possibility that there's going to be a disease outbreak where they have to eradicate their animals. And the long generation interval of animals makes it really difficult to bounce back from that. And that includes foreign animal diseases, foot and mouth disease, African swine fever. If they make their ways into the borders of North America, our biodefense strategy is just mass eradication. And then we got to repopulate. So that keeps them awake at night. The other is, how do we integrate our edited genomes that are resilient to diseases or thermotolerant into large populations? And that requires reproductive technologies. We have to be able to efficiently disseminate genetics through reproduction. And traditional strategies to do that just aren't sufficient. So I think addressing disease resistance and resiliency, and then new technology in reproductive biology or reproductive technologies.
Excellent. Ian?
For me, we can now focus not just on the quantity of calories, but the quality of calories worldwide. Corn and soy have been intensively bred for a very long time and increased productivity. This technology allows us to spread that to a variety of different crops grown in different parts of the world and allow access to more nutrition in a variety of places. So I think the impact on human health could be quite profound over the next 20 years. So I'm really excited to see this technology democratized. It's part of the reason why we pretty freely out-license the technology that we create, particularly if folks are working in the Global South or other areas, because we really do think this can be a truly transformative technology.
Agreed. And I'll just add quickly that, we've been talking for a couple of decades about the difference and the distinction between benefits to growers and benefits to consumers, and we even did that today on our panel. But what excites me about gene editing is we're going to be able to have both of those into single packages. So we're going to be able to have great products that have benefits to growers as well as benefits to consumers in one fantastic gene-edited crop. Thanks.
Excellent. Well, I hope you all learned something about this technology today and how it can benefit us all. And thank you to my panelists.